welcome back. Today we're going to be talking about factoring polynomials where a is equal to 1. Now let's take a look at some important vocabulary. Today we're going to be talking about quadratic expressions, and a quadratic expression is an expression with a variable and its highest power is 2. The quadratic expression is written as ax squared plus bx plus c. So for example, x squared plus 12x plus 36. This is a polynomial to the second degree because of the second power. So here are some keys to factoring. So we're going to find two factors when multiplied together will equal the quadratic expression, and the factors are going to be binomials. Now let's look at some factor puzzles. So here are factor puzzles, and factor puzzles for quadratic expressions may not have common factors right away, like when we learned about GCF. So we use a factor puzzle to help us. So let's try a few examples. So we were going to look for things that multiply to 2 and add to 9. So if we're thinking about that, we could say, okay, 4 times 5 gives me 20, and 4 plus 5 equals 9. If we're going over to our factor puzzle on the other side there, it says negative multiplies to negative 14 and adds to 5. So we can say, all right, that's going to be 7 and 2 multiply to give me 14, but I need to make sure that it adds to 5, and one of them has to be negative in order to have a positive times a negative, giving me a negative. So if I think about that, I'm going to have a positive 7 and a negative 2, because positive 7 times negative 2 will give me negative 14, but if I add 7 and negative 2 together, that's going to give me 5. So these are factor puzzles, and they'll help us when we're talking about factoring. So now let's take a look at the steps to factoring. So here are our steps for factoring. So we're going to complete our factor puzzles, the things we just did before. We're going to write an expanded form. Now notice that this step is underlined because it's very, very important. Then we're going to group into binomials, factor out any greatest common factor that exists, and then we'll rewrite our binomials after we factor out our GCF. So now let's take a look at example A. So here we are at example A, and it says factor the expression completely. So I've got ax squared plus bx plus c is my equation, and I can see here that I've got my expression below, x squared plus 8x plus 15. So I'm going to label my a as 1, my b is 8, and my c is 15. And that's going to be helpful because I'm going to complete my factor puzzle by multiplying a times c. So a times c is going to be 15 because 1 times 15 is 15. And my b is going to be 8. So just like before when I was using my factor puzzle, I'm looking for things that multiply to 15, they give me 8. So I've got a positive 15 there, positive 8, so I know that 3 times 5 will give me 15, and that 3 plus 5 is equal to 8. So now I'm going to write that out in expanded form. So I've got x squared plus 5x plus 3x plus 15. All right, that's great. So I've written out in an expanded form because I've taken my middle value there of 8x and made it 5x plus 3. Now I'm going to factor it into binomials. So on one side, I've got x squared plus 5x, and on the other side, I've got 3x plus 15. So now it's time to factor out common denominator, or greatest common factors. Oh boy. So I've got x squared and 5x. I can take an x out of that, so I'm going to end up with x on the outside there, and then an x squared divided by x is x, and 5x divided by x is plus 5. All right, I'm going to do the same thing on the other side. I can take out a 3 over here, so I'm going to have 3 on the outside. 3x divided by 3 is going to be x, and 15 divided by 3 is going to be 5. All right, so now do I have common factors that I can take out? I can take out an x plus 5 because they are the same on both sides. So I've got x plus 5 as one of my common factors. And then the only thing that's left is an x and a positive 3. So my other factor is x plus 3. And there we go. I've got my binomials completely. X plus 5, x plus 3. Now let's take a look at example B. So here in example B, I've got x squared minus 6x minus 40. So again, I've got A, I've got as 1, B is negative 6, and C is negative 40. So I'm looking for things that multiply to negative 40 and add to negative 6. So if I'm doing some math, I could say, okay, I know 10 times 4 will give me 40, so that's good. But I got to end up with a negative 6. So one of those is going to have to be negative, one of those is going to have to be positive. So it's going to be negative 10 and positive 4, because plus 4 to negative 10 is going to give me negative 6. Positive 4 times negative 10 gives me negative 40. So that's great. Let's write this out in expanded form now. So now I've got x squared plus 4x on one side, minus 10x, and then minus 40 on the other side. So now again, I'm going to look for that greatest common factor. So I'm going to take my two things here. So x squared and 4x, the thing that I can pull out is an x. So I'm going to have an x on the outside, and I'm going to have x plus 4 left on the inside. On the other side, I can pull out a negative 10. So I'm going to make sure that I do that. So I'm going to pull out a negative 10 here. So let's bring our negative 10 to the outside, negative 10 to the outside. There we go, negative 10 to the outside. And on the inside, I'm going to be left with x and minus 4. No, plus 4. Plus 4. Yeah. All right, so we're going to pull out our factors that are common. And in this case, it's x plus 4. So that's going to be one of my factors. And on the other side, I'm left with x and negative 10. So x and negative 10 is the other factor. Now let's take a look at the next example. Here we are in example C, and I've got, again, x squared, 3x, and negative 18. So A is 1, B is positive 3, C is negative 18. So again, 1 times negative 18 is negative 18. B is going to be 3 in this case. So I'm going to be looking for things that multiply to negative 18 and add to 3, which is going to be tricky. But luckily, I know 6 times 3 is going to give me 18, and that's great, but I need one of them to be negative and positive so that I can end up with a positive 3. So if I have a positive 6 and a negative 3, that'll work out in my favor because 6 plus negative 3 is positive 3, and negative 3 times 6 is negative 18. So let's write that now in expanded form. So I've got x squared plus 6x minus 3x minus 18. All right, so now we're going to be looking for some factors here. So we're going to pull things out. So on one side, I can pull out an x. So I've got x on the outside. X squared divided by x is x. 6x divided by x is positive 6. On the other side, it looks like I can pull out a negative 3. All right, so I'll have negative 3 here. Negative 3 divided by negative 3 is going to be x. Negative 18 divided by negative 3 is going to be positive 6. Okay, so what can I pull out there at the end? Looks like x plus 6 and x plus 6 is going to be one of my factors. And then I've got an x and a negative 3 left over, so x negative 3 is my other factor. Now let's move on to the next example. So here in example D, it's a little different because this time my a is not equal to 1, it's 2. But the good news is I can make it 1 because I can see that I have a greatest common factor. I have 2, negative 24, and positive 70 as my numbers, and they can have a greatest common factor. All of them can have a 2 taken out of them. So before I even begin, I'm going to remove that 2 by taking out 2 in the greatest common factor. So when I do that, 2 divided by 2 is going to be 1, so now my a is left with 1. My negative 24 divided by 2 is going to give me negative 12, and 70 divided by 2 is going to give me 35. So now that I've taken out that 2, now I can go about factoring, and I'll bring that 2 back in at the end, not to worry. So I've got my negative 12 is what I want to add to, and I want to multiply to 35. So if I'm thinking about that, that's going to be 3 times 5, but I need them both to be negative because I want a positive thing that I multiply and a negative that I'm going to get. So I want negative 7 and negative 5, because negative 7 times negative 5 will give me positive 35, but negative 7 plus negative 5 will give me negative 12. All right, so let's write out what we've got in expanded form. So in expanded form, we're going to have x squared minus 7x minus 5x, and then plus 35. All right, so let's take a look at our common factors. So things that we can pull out of the first set is going to be an x. X squared divided by x is going to be just regular x. And negative 7 divided by x is going to be negative 7. On the other side, I can pull out a 5. But I want to make sure that I pull out that negative there because I'm going to be pulling out that negative from my leading coefficient. So I'm going to make sure that that's a negative 5 that I pull out. When I do that, negative 5 divided by negative 5 is 1x. But positive 35 divided by negative 5 is going to be negative 7. Fabulous. Okay, so now let's check, do we have a common factor here? So we do. We can pull out that negative 7 in both cases. So x minus 7 going to be one of my factors. Then I'm left over with x and negative 5 as my other factor. But I need to make sure that I remember that I pulled out that 2 to begin with, so I bring that down to the front. So now that my final answer is 2 times the parentheses x minus 7, parentheses x minus 5. Let's take a look at the last example. All right, here in the final example, I've got x squared minus 19x plus 20, so that's going to be 1 and negative 19 and positive 20. So 1 times 20 is 20, and we're going to find things that add to negative 19, and then, well, if we multiply, let's see, 1 and 20, that would give us, well, if we had a negative 1 and a 19, oh no, this doesn't have any factors that can be multiplied to 20 and give us add to negative 19. So in that case, we know that this is known as prime. So when we have a trinomial where we can't find any common factors or any factors that multiply a and c together and add to b, that is known as prime, and we just write the word prime. There's no more things to write. That brings us to the end of this question. It also brings us to the end of this set of notes and this video. If you like this video, go and say thumbs up. If you love this video, go and say sub, and we will catch you in the next one.